Probability distribution, by definition, is just the theoretical estimate of the actual distribution of probabilities. Given that any situation we could have a number of different outcomes, the probability distribution is to calculate the probability of each of those outcomes occurring and giving it as a set. So probably the best way to explain this once again is by an example. So toss 3 coins, and we've done this before, but very quickly you could do a quick tree diagram. First coin, second coin, and third coin. So we can get a head or a tail on the first, head or a tail on the second, and a head or a tail on the third. And a sample space going along the branches, head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. So all up, 1, 2, 3, 4, 5, 6, 7. There are 8 different outcomes. Each of these are going to have a probability of, they're all equally likely, of 1/8. And because there are 8 of them, the total of the probabilities, when you add them all up, will be equal to 1. Well, thought I was one short. Okay, so that's the tree diagram, so you know that each of these has a probability of 1/8. Now, if we were interested in this little experiment here of the number of heads, so X is the number of heads, and that's our shorthand for number of. The values that X could take, and this is using set technology here with the curly brackets. So if we look up here, the number of heads, well, we could have, let's start at the bottom here, we could have 0 heads, and then a number of these has got 1 head, 2 heads, and 3 heads. So we could be interested in the distribution of the probability, 3 heads. We could be interested in the distribution of the number of heads and work out all of these different probabilities of 0 head, 1 head, 2 head, and 3 head. So what we could do is put that in a table. And we could have little xi being the different values of here. So this will be little x1, little x2, so they are all the possibilities for big X. And this would be the probability that x is equal to xi. Okay, so we've said that there's 0, 1, 2, and 3 are all the different possibilities of xi, that is the number of heads. So 0 heads, how many times here do 0 heads occur? Only once, so that'll have a probability of 1 on 8. How many times here do we have 1 head? So we've got this one, and this one. So there's 3 of those, so this will be 3 over 8, 3 lots of 1/8. How many ways up here do we have 2 heads? So we've got that one, and that one. So once again there are 3 of those. And how many ways do we have 3 heads? And there is only 1 of those, so 1/8. Notice that when you add up those probabilities, 1/8 plus 3/8 plus 3/8 plus 3/8, 1 plus 3 is 4, plus 3 is 7, plus 1 is 8 on 8. Which is equal to 1. It will always happen that it'll add up to 1. Okay, now we could also put this into a bar diagram, and we could have the probabilities 2 on 8, 3 on 8, and we could have 0 heads. This is X, which is the number of heads. 1, 2, 3, and this is the probability. So we've got the x-axis being xi, the number of heads, and then we're going to put the probabilities up on the right hand side. Probability that x equals xi. So looking at our table up here to graph this, so 0 heads is 1 on 8th, so we could, if it's going to be a bar diagram, go like that. 1 head is 3 on 8, so we've got 1 8, 2 8, 3 8, so it's going to go up. And so on. 2 heads is also 3 8s, and 3 heads is back down to 1 8. Okay, so that's a bar graph showing the probability of all the different outcomes, the probability distribution for tossing 3 coins. Another variation on this is just to do, so this is a bar graph, and we can do a probability distribution, a probability histogram. Now a histogram, if you like, they are wider columns and they must join. A histogram, the columns actually join. So we've still got our 0, 1, 2 and 3, and we've got our probabilities going up here, 1 on 8, 2 on 8, 3 on 8. Now the thing to remember with histograms is that because they join, we've got 3 on 8, so it's going to go equal either side. So there's 1, which is 3 on 8s. This one here is 1 on 8. And 2 on 8 is the same. And 3 on 8. Okay, so we put our labels on our axes. And over here we've got probability. Okay, so that's a histogram, that's a bar graph. The thing to remember with histograms is that the columns all join up, they butt onto each other, there's no gaps in between. Whereas with a bar graph, they're quite thin and go up. They're still displaying the same distribution. Here, the information is displayed in a table, and we'll continue with this at a later date.